Everyone, today I'm going to give you another example of how to solve a linear first order differential equation. So we're given this differential equation, x times dy over dx minus 4y equal to x to the power 6 or x to the 6th power times e to the xth power. Alright, so to solve this problem, we just follow the procedure on how to solve a linear first order differential equation. So what is the first step? So the first step, we have to see if the given differential equation is in the standard form. Okay, so first we have to remember what's the standard form of a linear first order differential equation. So the standard form is given as dy over dx plus p of x times y, or function of x multiplied by y, equal to a function of x. So that is the standard form of a linear differential equation. So if you look at the given, is it in standard form? Okay, so look at the first term. So it's not in standard form because there is a coefficient of x of our first derivative of y with respect to x. And then the middle term is not positive, this is negative, right? The right side is okay, it's purely a function of x, so we have no problem on the right side. So we have to do something here. Okay, so what we need to do is first transform it into its standard form. This one. So let's make this equation like this. So how? So we are going to remove this x, the coefficient of dy over dx. So to remove that, we need to divide both sides. So first, let's rewrite the given x times dy over dx, then minus 4 times y equal to x to the 6th power times e to the x power. Then after that, to remove this, we have to divide both sides. So let's divide both sides by x. Okay, divide this by x also. So what will happen is, okay, let's transfer this equal sign here. Something like that. So we have to divide each term. Oh, we have two terms on the left side, so we have to divide each term by x. So this becomes x times dy over dx, divide this by x, then minus 4y divided by x equal to x to the 6th power e to the x divided by x. And now we can simplify. So we have x at the numerator, x at the denominator cancels out, so leaving only dy over dx as our first term. Then this one, to follow this, we have to make this positive. Okay, so how to make that positive? And we can rewrite this as negative 4 over x times y equal to x to the power 6 divided by x, so that will be x to the power 5, from the low exponent, e to the x. Alright, so it is now in the form of, or it is now in the standard form of a linear differential equation. So after that, we have to find out what is our mu of x. Okay, we have to find out what is our mu of x, because we need to, the procedure says that after finding the mu of x, you have to multiply each of this term on the left side and right side by the mu of x. Okay, so what is our mu of x? Our mu of x, or first we have to find out also what is our p of x. So from here, our p of x is simply equal to minus for x. Then our f of x, is this one, right? So our f of x is equal to x to the 5th power e to the x. But what we need now, importantly, is this one. Okay, because we have to find what is our mu of x. So our mu of x is given by the formula e to the integral of p of x dx. Okay, and then substitute e to the integral of our p of x is equal to minus x over 4. 4 over x. Sorry for that. Then multiplied by dx. Then we can rewrite this as, we can put the constant outside of the integral sign. So e to the minus 4 integral of, we have dx over x. Okay? So what is the integral of dx over x? So the integral of dx over x is simply equal to e to the minus 4 times ln x. Then from algebra, so we will apply the properties of logarithm. So we can write this as e to the ln x raised to a power negative 4. So we have to put this negative 4 as the exponent of this. So that is properties of logarithm in algebra. Alright, so after that, we can rewrite this as, we can bring this down, x to the minus 4, then multiply this by ln e, where ln e is equal to 1. Oh, this is just equal to 1. So 1 times x to the power 4. So this is x to the minus 4. So this is our mu of x, or mu x, or a function of x, mu x. So this is the factor that we are going to multiply, because this is the second step, no? The second step is to finding the mu of x. Mu of x is equal to, this is equal. Okay? So next, the next step that we're going to do is to multiply its term. Its term of this, the standard form of the given differential equation. This is the given differential equation, and we transform this into its standard form. Then we got the mu of x, so we have to multiply this mu of x, each of this term. So we can rewrite now dy over dx, multiply this by x to the minus 4. Okay, then plus, we have x to the minus 4, then multiplied by negative 4 over x times y equal to x to the minus 4 multiplied by x to the power 5 times e to the x. So what we're doing now is the third step. Alright, then combine similar terms, or simplify this part here. So we can now rewrite this as x to the negative 4th power times dy over dx. This one minus, we can combine, we can bring this down, okay, from the low exponents. So we can rewrite this as, so this is negative, positive, so this is negative. Okay, then you can bring this down. Then we have 4, okay, 4 in times y divided by, so this becomes positive when you bring that down, so to the power 4. Then we have x equal to, so we combine this from the low exponents, so we can write this as x, because from the low exponent we have the same base, this is multiplication, so you just add the exponents. So when you add negative 4 and 5, so this will become x to the power 1, or no need to write the exponent 1. Oh, that's from algebra. Okay, so that's the resulting expression now. And we can combine this from the law of exponent. So x to the minus 4 times dy over dx minus 4 times y divided by x to the positive 5, okay, equal to x times e to the a to the x. Okay, so what is the fourth step? If you look at this, so let's check this one. The fourth step is to look at this expression if this is just the let's check if this is just the product of, or the derivative of mu of x. Okay, so I will just rewrite it, mu of x, or the equivalent, which is this one, or you can write this, and y. Okay, then mu of x, so let's check if this is mu of x and f of x. So we know that this one is just the product of mu of x and the f of x. So rewriting this, x times e to the x, and then if you look at this, so derivative of our mu of x is equal to x to the minus 4 times y. So let's check if this one is really exactly equal to this one. Alright, so how to determine if this one is exactly equal to this one? So let's use the derivative of the product, product rule. We will apply product rule here. So the product rule says that, okay, I will write it. If you take the derivative of say u and v with respect to x, so this is equal to, okay, I will, okay, so derivative of u with derivative of u times v with respect to x is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So let us see if the left side of our differential equation really exactly like this. So if that is really the derivative of the product of mu of x and y. So this is our u and this is our v. Okay, so let's check. So if this is really equal to this one, so let's check. So if you take the derivative of this, okay, so let's take the derivative of x to the minus 4 times y, okay, with respect to x. So let's check if, so this is our u, this is our v. Alright, so the formula says u, our u is x to the minus 4, okay, then times the derivative of v, our v is y, so derivative of y with respect to x, then plus v, so our v is y, okay, and then derivative of x to the power 4, so derivative of x to the power 4. So what is the formula in finding the derivative of a power? So derivative of this, you subtract 1, okay, so you subtract 1. So what will happen? So this will become, the power will go down, then you subtract, so this becomes minus 4, okay, then x to the power minus 5, right? So that's the result after differentiating this y with respect to x. Okay, then simplify. So this is x to the minus 4 times dy over dx. So minus, plus and minus, so this will be minus. We have 4, then we have y, so 4y, then this x to the power minus 5, you can bring that down. That will be x to the power 5. Okay? So look at the result. Is this equivalent to what we have here? So let's compare. Okay, so first term, x to the minus 4 dy over dx, correct. Second term, 4y divided by x to the power 5, correct. So therefore, this expression can be written as something like this. So we have proven that this one is just the product of mu x, or some function of x, which is mu x multiplied by y. Okay, after that, we have to integrate. So that is the last step. Step number 5, we have to integrate both sides. Okay, so I will just rewrite this. The derivative of x to the minus 4 times y with respect to x is equal to x times e to the x. Then we integrate both sides. Okay, so when you integrate both sides, we have here dx, and so with this one. Okay, so we know that differentiation and integration are the opposite process. So we have dx here, okay, and dx. You have the differentiation and integration. We know that they are just the inverse process. So it means that the left side will just be x to the power 4 times y equal to integral e to the x. So what shall we do with this? So we can integrate this using by parts. So what is this by parts? Okay, so I will write it here. What is the formula of by parts? We have so the by parts formula, no? By parts. I'll move this on. So what is the formula of by parts? Integration by parts. We have integral of u dv equal to u times v minus integral of v du. Okay, so now we have to find out what is our u, what is our v. So from here, if we consider this as our u, okay, then we consider this as, okay, so our u here is equal to x. Then what is our dv? Okay, our dv is so what is the dv? If this is our u, because you have integral of u dv. So if this is u, so let's check if this can be our dv. If we consider e to the x as our dv, so let's check. So we have the formula. We will use the formula. Now another formula, we have the integral of e to the u du is equal to e to the u plus c. Okay, so in this case, what is our u? So we have another u. It has nothing to do with this u. So just for our dv, we have to find the u here, so which is equal to x. So our du is equal to dx. So this is a perfect dv. So it means that we can integrate this. So when you integrate this one, so what is the integral of e to the u du is equal to e to the u plus c, or this is equal to our dv. Sorry, when you integrate this, we have integral process, differentiation process. So the left will becomes v, and this is e to the u, or u is equal to x. Okay, so we have u. We need to solve for du. Du for this one, so du is equal to dx. So the formula is, what is the formula? You just multiply u and v. Okay, so multiply u and v. So we have here x to the minus 4 times y equal to u v. So we have u is x, then multiplied by v, which is e to the x, minus the integral of what? The integral of v du. So what is our v? V is e to the x. Our du is dx, so times dx. So again, when you integrate this, So x times e to the x minus, so this is the same as what we did a while ago. So here we can have our u as x, then our du as dx. So let's check if we can use the integral of e to the u du. So when our u is x, our du is dx, so this is exactly e to the u du. So we can integrate this using, or we can get the equivalent function after integration of this expression or this integral. So this is this is just e to the x, then plus the constant of integration. Okay, so next we have to, if you look at this, they have common, which is equal to e to the x. So we can factor out the common, e to the x. So this becomes x minus 1 times, plus c. Then the right side we can apply the low exponent here to bring this down. So we have, if you bring that down, that becomes x to the power 4. Okay, so let's continue it here. So this becomes, I'll just rewrite this, y over x to the 4 equal to e to the x times x minus 1, then plus c. Then solving for y, we can multiply both sides by x to the power 4. So we have y equal to x to the 4th power times e to the x times x minus 1, then plus c. Or simplifying this, we have y equal to, this can be written as, distribute this one, we have x to the power 4 e to the x times x minus 1 plus c times x to the power 4. Or, so this can be your answer, or you can also distribute this one if you like. So if you multiply this, so this can be x to the 5th power e to the x minus x to the power 4 e to the x plus c x to the power 4. So they're just the same. So either of these answers would be okay. Okay, so that's it. That's how to solve this second example of our linear first order differential equation. So we just follow 5 steps in order to solve a problem like this. Alright, so that's all. Thank you very much. And if you have any questions or if you have any comments, you may leave your questions or comment in the comment section below. Thank you.